Good? Yeah. Okay. So yeah, Holocene dynamics of sugar maple populations at the northern limit in Quebec. So first off, we're going to start out by taking a look at the at Quebec's forests, and just recently we were in the Arctic, in the ecotone between the Arctic forest and the boreal forest. That's a bit too northern for me. There's not many maples up there, so we're going to go back down to the ecotone between the boreal zone and the northern temperate zone. So sugar maple has its limits right around here, right at the ecotone, and another tree species which is very important to sugar maple's distribution is actually red maple, which is just above the ecotone line, right over here. So right at the mixed foot, right where the mixed foot becomes more border. And seeing as how sugar maple is a more temperate species, we looked at initially the two main periods of temperature in Quebec, and we had in Quebec we have as much as the rest of the world we have the thermal optimum, but because of the presence of a glacial cover over Quebec, it's a bit it starts a bit later, so around 8,000 years ago to around 4,500 years ago, and afterwards we have the neoglacial cooling period, which starts off at around 4,000 years ago and continues to the present. So sugar maple is a temperate species. We expect it to grow better in warmer conditions, and the thermal optimum was indeed warmer. And on mesic sites found at those latitudes, fire was actually less present, less frequent than elsewhere. So we're expecting to find higher abundance of sugar maple during the optimum and a reduction in abundance during the neoglacial cooling. However, an initial analysis of lake pollen data actually found it was quite the opposite. So pollen data indicated that sugar maple was not abundant at all during the thermal optimum, and only at the beginning of the neoglacial cooling did pollen signal actually indicate that the species was local. So these just surprised us, and we decided to go a bit further with other analyses just to confirm them. So this is the main objective of this study, is to see how the ecological dynamics of northern maple populations vary throughout the Holocene. And now pollen is great. However, it's not too well adapted to studying marginal populations, especially marginal populations of an underrepresented species like maple. So maple doesn't produce a lot of pollen, and the little pollen that is deposited is difficult to determine whether it's from a local influx or from a regional influx. So instead of using pollen, we decided to use soil charcoal from the marginal stands themselves. So what we did was collect 420 samples, soil samples from 6 sites across the width of the region that we wanted to study. Then we identified the charcoal via microanatomical structures. Around 2,500 charcoal fragments identified, and then we dated 96 charcoal fragments to establish a history. So here are our sites. As I said, 6 of them, and the results from the charcoal data show that maple species, not necessarily sugar maple, but red maple, was actually present at this line close to the deglaciation of the region, which is around 10,000 years ago. And then afterwards, it was abundant around. It was present around 8,000 to 6,000 years ago. We found our first signs of sugar maple, and then after around the beginning of the neoglacial cooling period, around 4,000 years ago, we see an increase in the abundance of sugar maple and red maple across the whole region. And now, regional studies, once again, they're all fine and well, but charcoal studies are not necessarily at their best when looking at a regional scale. So what we decided to do was concentrate on a single site where we had 3 sampling locations. So on the first location was our maple hill. So maple stands at the margins are only located on the top of hills. On mesic sites, and so we decided to study that, an adjacent hill which had no maple on it, and a valley stand which was pretty representative of all the other stands found around the base of the hills, which was mainly coniferous. And the results were, once again, a bit surprising because we found that on our maple-free maple-free hill, we actually had presence of sugar maple until very recently. So in the last millennia, we actually had fires which created sugar maple charcoal. On our maple stand hill, we also had maple charcoal. However, it was a bit older, and down in the valley we had no maple at all. So these results show us is when we control for climate. So basically, we suppose that given the proximity of the two maple hills, the climate is going to be pretty similar. When we control for climate, we can see that fire is actually the process that determines whether or not maple is present on that hilltop. And when we control for fire, because of the proximity between these two, actually we sort of we don't necessarily control for fire, but we actually differentiate in climate. So here we see there is no maple at all. So that basically means that if the climate is not good enough, maple cannot establish itself. So it's basically, that's why it's limited to the hilltops, is because of climate conditions. Now, the secondary objective, the second chapter of my doctorate thesis, would be to add another proxy to this analysis. And while pollen and charcoal form pretty much the extremes of spatial scales, pollen being quite regional and charcoal being quite local, we decided to use sedimentary DNA, ancient sedimentary DNA, which cuts that spatial scale right in half, because while pollen influx can come from very far away, and where charcoal has to be located directly where the tree burned down, DNA is actually on the scale of the watershed of a single lake. So we reduce the uncertainties of the influx location for pollen, but because of the presence of a stratified sample, we actually reduce the necessity of high sampling effort found for charcoal. So it's pretty much the best of both worlds, we assume. So this chapter is beginning right now. So what's basically happened till now is software selection for our primers, our selected primers, which we are then testing on live DNA. So pretty much very ideal condition DNA. So, and why we need to do this is because we're actually going to very specifically target our maple species using one primer set per species. And then we're going to have a primer set which is a bit more general for a couple of extra companion species. So that's where we're at basically on the selection of primers. And the next step would be the application of those primers to mix DNA samples to see how specific they really are. And then afterwards, of course, begins the testing of samples and all that. And the final chapter from the thesis would be an integration of charcoal, sedimentary DNA, and pollen data. So initially, a very quick mock-up of what integration looks like. So we see with the pollen that we have a really continuous, really nice, except this part, really nice data for pretty much all the Holocene, whereas charcoal data is quite a lot more fragmented. However, what's nice about this is that this is the line that separates regional influx from local influx. And as we can see down over here near the beginning of the Holocene, pollen does not detect local populations, whereas charcoal data does. So we have an increase in our resolution, but a decrease in the number of samples, basically. And what we hope is that sedimentary DNA will come right there and complete the missing links between both. And that's basically what I said. So in conclusion, what results show for now is that maples were present in their current margins since pretty much deglaciation, which was surprising because we expected them to have migrated during a thermal optimum. Their abundance was low during the optimum, but increased with neoglacial cooling. Once again, surprising because they are thermophilic species. And finally, fire regimes appear to be the process that control the distribution of marginal populations. And finally, this data is important because while it may be difficult for species like maple to actually migrate within the boreal forest because of competition and other factors, an increase in their presence in the mixed wood boreal forest, could actually mean a big change and maybe potentially even a transition from mixed wood to more deciduous forest. Thank you very much.
Thank you, Todor. Great talk. Is there any question in the room? We have time for one. Yes.
Hi, this might actually become a philosophical question because I guess there's also like speciation with time. But then, how confident are you that you find primers that are like resistant to mutation in your sediment cores as well, you know, from back in plants?
Yeah, well, based on literature, like other uses of ancient DNA testing, normally the problem isn't too much mutation, it's more degradation when the DNA is deposited. It's not a guarantee. There might be indeed some variation within the DNA that means that our primers don't work entirely, but it's difficult to say. And there isn't too much ancient DNA floating around, so we have to test it to find out. All right.
Yeah, thanks.
Thank you.